tsunamis taller than skyscrapers crashing into entire coastlines, earthquakes shaking continents into rubble, volcanoes awakening in chains, spewing ash into a year-long nuclear winter, maybe even Earth breaking apart or being knocked out of orbit. Well, almost. Today, we're going to find out what would really happen if humanity's most powerful nuclear weapon went off in the deepest known part of the ocean, the Mariana Trench. Welcome to Ufology. If you're new here, make sure to like and subscribe. It really helps us out and inspires us to keep bringing you more mind-bending science videos. The Mariana Trench is a colossal scar in the Pacific Ocean floor, sitting at the collision point of two massive tectonic plates. It's a steep, V-shaped abyss, as if someone flipped a mountain upside down and dropped it into the sea. At its deepest point, Challenger Deep, it plunges about 11 kilometers straight down. That's nearly 3 times deeper than the Titanic's resting place. It's a world of absolute darkness, crushing pressures over 1,000 times greater than the air you're breathing right now, and an ecosystem almost untouched by humans, which makes it the perfect place for our hypothetical test. We're not going small. We're using the Tsar Bomba, the most powerful nuclear device ever detonated. This Soviet-made hydrogen bomb unleashed the equivalent of 50 megatons of TNT when tested in 1961. Its shockwave circled the globe 3 times. Its mushroom cloud pierced the atmosphere 56 kilometers high. Its fireball could have swallowed a city whole. In short, it is humanity's biggest "don't press this button" moment, and we're about to drop it to the bottom of the ocean. At T equals 0, the bomb's nuclear fuel ignites in a runaway chain reaction. In less than a millionth of a second, trillions of atoms split or fuse, releasing an unimaginable surge of energy. A blinding flash tears through the pitch-black trench, the first light these waters have ever seen. The bomb creates a superheated bubble of vaporized water, glowing plasma, and whatever unlucky sea life was nearby. This bubble doesn't just expand, it slams outward, vaporizing everything in its path and shoving the surrounding water aside with the force of millions of tons of TNT. In the open air, this fireball would expand to over 10 kilometers wide in a single second. But here, under 11 kilometers of water, the crushing pressure fights back. Within a second, the bubble reaches roughly a kilometer across before slowing down, losing pressure, and being forced to collapse inward. Then, like a spring snapping back, it rebounds, expanding, then shrinking again, in a violent back and forth. This underwater breathing effect happens several times, until the surrounding pressure finally wins. The once mighty bubble fragments into countless smaller, radioactive hot pockets that begin their slow, deadly rise to the surface. After traveling upwards for minutes, the blast finally reaches the open ocean, and instead of the towering mega tsunami we might expect, the surface barely flinches. At most, there's a foamy plume of warm, radioactive water and a small wave, something that might rock a nearby fishing boat, but won't flatten Tokyo. The Pacific Ocean is just too vast. It disperses the blast energy almost instantly, like a stone tossed into a swimming pool the size of a planet. The plume carries radioactive isotopes upward, some mixing with the atmosphere, others dissolving into the water. Within days, ocean currents spread this diluted radiation across huge distances. Most of the fallout would end up far out at sea, but some would eventually rain down over land in tiny amounts compared to historical nuclear tests. It's dangerous for marine life in the immediate blast zone, but not an extinction-level event for the ocean. You might imagine the explosion punching into tectonic plate boundaries, unleashing devastating quakes, but the reality is disappointing. Yes, the bomb would vaporize part of the seafloor, even turning sand into glass-like fragments. But most of the energy gets eaten by the water, not transferred into seismic waves. Earthquakes with a similar energy release happen naturally several times a year, and they rarely trigger chain reaction disasters. As for volcanoes, They operate on geologic timescales, not human ones. The odds of our blast waking a sleeping giant are almost zero. No, our planet is unimaginably massive. Even 50 megatons is microscopic compared to the forces that move it. For perspective, Earth's daily interaction with the moon's gravity exchanges more energy than every nuclear bomb ever made, combined. Also, over 2,000 nuclear devices have been tested since the 1940s, and Earth's orbit hasn't budged a millimeter. After all that, the most powerful bomb in human history barely dents the ocean. No doomsday waves, no planet-cracking quakes, no orbital shifts. Instead we get a brief underwater light show, a collapsing bubble of boiling water, some localized radiation, and a mildly confused population of deep-sea creatures. The deep ocean swallows humanity's mightiest weapon and shrugs. If anything, this little thought experiment shows just how small we are compared to the forces of nature. The planet is massive, it's resilient, and it doesn't care about our biggest explosions. If you enjoyed this dive into what-if science, you can support Ifology by subscribing and ringing the bell. It helps us bring you more mind-bending, curiosity-driven videos, because in science, the more you ask, what if, the stranger and more amazing the answers become.